All right, welcome back everybody. Data, voice, and video cabling. It's chapter 3, overview of wiring installations. What I'm hoping we get out of this chapter is do we understand the essential elements of a safe cable system installation, not just safety as in how to work on a ladder, safety for the buildings that you're working in, making sure that we're adhering to proper codes, and just following the basic guidelines. Some installers do everything. Some installers will handle all the fiber. Some installers will do the coax. Some installers will do the drilling of the studs in the walls and do everything. Some installers will even do all the electricity that goes within it. One caution cannot be overemphasized when we're talking about installation is that if you are not fully confident that you know how to do something, okay, then you might just not want to do it, or get the proper training to do the job correctly. Good training, working with people who have experience, making phone calls to application engineers, calling manufacturers, calling distributors can alleviate a great deal of the problems that a lot of us run into when we're doing cable installation. Installing cable and its associated work is by far one of the bigger parts of installing our telecommunication systems. Once it's in, it seems, it's in. Uh, we're going to cover installation in some detail, copper wiring. We'll talk about telephone systems. We'll follow up with video and then finish up with networking. Each application uses different components. Almost all fiber optic projects will use similar components, so we cover them in one section altogether. Now, when it comes to installing our equipment, we want to bear in mind that cabling must be installed according to the requirements of the NEC, the National Electrical Code. You also want to take in consideration all of your local codes that you might have in your municipalities. In addition, there are accepted voluntary standards and guidelines for installation of voice and data networks. They were created by groups and vendors so that all the different components could work with each other. We call these standards. These standards were pretty much put together by the TIA-EIA. 568 is the standard. These standards may be called out as references in your design networks. For example, the TIA-EIA 568C is the Commercial Building Code standards, which is the ones that we typically will follow the most. And then we're working within our pathways. It's the TIA-EIA 569. Finally, you have to remember one thing. It's probably most important is that the customer has the final word in everything. The customer has the final word because the customer is the guy with the checkbook. He's the guy who's going to be paying for our services. Now, that does not mean you can cut corners, because you cannot cut corners. You must still put everything in up to building code, but if the customer wants some other things in there, hey, by all means, they're paying. So whether you're installing voice, data, or video cabling, whether copper or fiber, there are certain guidelines that we want to follow. Work with the correct design, okay? Make sure that you follow the design drawings, blueprints, all codes are taken in consideration. Make sure your cable lengths are not too long. Choose your proper components, okay? If you're working with Category 6 cabling, then make sure that all your components that your terminations are all Category 6. Don't abuse your cable. Don't over pull. If you pull too much on a cable, you'll actually lessen the amount of twists per inch in the cable, which will cause crosstalk issues. Also, make sure that you do not overbend, go past your radius limits. Riser cables have special limitations that must be followed. Don't overfill conduit or run cable too far and have it unsupported so you don't have big sags. Remember, if you use cable ties, make sure they're snug, okay, but not too tight. And then also make sure you cut off the little tails at the end of all your cables, okay? Watch out for interference. Keep copper signals away from power lines, fluorescent lights, electric motors, and so on. Um, Consider upgrading requirements. If the user plans major upgrades in the network someday, consideration of this should be taken in. For example, if your customer is planning on moving to gig networks or 10 gig networks in the future, you sure as heck don't want to be cutting corners and putting in Cat 5e cabling. Think about any move changes. If customers might be moving equipment, uh, so you might want to add additional drops and put those in place. Um, Make sure that the equipment that's going to have to be powered or whatnot will be properly protected. One of the things you want to look at is your telephone equipment. Okay, and as we work through the material, we're going to look at telephone wiring, which was the root of how it all began. Now, although we do not do a lot of telephone wiring today in buildings, especially with the 110 and the 66 blocks, it is where it all began. Um, for most practical purposes, we can consider telephone technology as the root where it all began, but then we'll go through and look at the video and we'll finish up with our computer networking. Telephones, the main concern here is that the proper phone is connected to the proper location. Punch down blocks, it's important that punch down blocks are mounted securely. Wall jacks and connection modules. Um, the two main concerns here, one, that the conductors are terminated in the proper order, and second, that the jack or module is secure, because it can suffer a fair amount of abuse during its useful life. The equipment racks, for larger systems, might require an equipment rack. You want to make sure that they are secure to the floor. They come in usually like 7 feet tall, and they can tend to be a bit top heavy. So if need be, make sure that they are fastened to the floor. Make sure they are grounded properly. And then central consoles, make sure that they're properly placed and must be installed near a source of electrical power, obviously. Now, for video equipment, one of the most common pieces of video equipment that we want to look at will be cameras and their mountings. Make sure that there are because there are many types of mounts available, and every camera needs to have a mounting bracket. First of all, the cameras must be mounted securely. Especially true because a little bit of wiggle on a camera mounting can give you image that jumps widely on the monitor screen. Monitors, for security purposes, are usually installed in some type of frame or case. As long as you screw them in correctly, you shouldn't have any problems. Items like switchers, sequencers, video recorders, motion detectors, and other items, just make sure they're securely mounted and properly connected. Antennas, these items must be secured to withstand years of wind, rain, snow, and the just all the beatings of a typical weather system. Some concerns are wind resistance and lightning protection for our cameras. Cameras can sometimes act as a wicked bad lightning rod. For our computer networks, on the other hand, you want to look at your personal computers. Okay, these machines obviously want to be properly placed and properly connected. They must also be properly fed with power, provide surge protection. In many cases, you may want to use a UPS, an uninterruptible power supply. Computer cards, when modifying an existing system, you have to install computer cards in PCs. They might require some experience with computers, A+ certification. If you're taking this for one of our hack classes, then you should already have had your electronics 125 and 126 as a requirement for your computer networking degree. Mini computers and small mainframes, these units require careful grounding, many times isolated ground, some conditioned power might be needed for these environments. Hubs, multiplexers, and routers, though we really don't use hubs anymore. You want to just categorize them in the same area if we would our switches. The main concern of these devices is that they're protected from damage. Obviously, they're not going to be set outside. You want to make sure that they're grounded and then free from extra abuse. Your peripherals, things like your modems, your printers, separate drive, and so on. A main concern here is that the devices will be safe from harm and tampering. Your large central unit are essentially dedicated computers uh, connected to switching units. So when you're installing these, you have several concerns. First, you want to be sure that there's plenty of space to install a unit and uh, enough room to access it during the installation process and afterwards for servicing. Some large computers have strict guidelines for cooling. Rarely do they need liquid cooling, as did the early mainframes, but they may need some air conditioning for reliable operation. Software, all computer network installations will require installing the network operating software. Uh, this is not a job that typically an cable technician is going to do. Typically, you would have your network administrators working on those items. When it comes to safety, guys, always wear proper clothing. You know what I mean is if you're working in an area where there's objects overhead, hard hat, okay, safety glasses at all times. Gloves can help prevent cuts when working around sheet metal. Even steel-toed shoes may be recommended for some construction sites. The wire you're installing is a conductor of electricity, so be careful for electrical shock. Identify any cables that are to be cut and removed before you do any cutting. Know where all electrical cables are and do your best to avoid them. Observe ladder safety rules. Okay, many installations require work above ceilings on ladders. Uh, we do not stand on top of ladders. And then when we're looking at the management of our installations, so when you begin to take on communication projects, it's critical that you know how to supervise the work of your other people. Be familiar with the power wiring in the area. Think of supervision as primarily as making sure that the work gets done on time and safely. Make sure that the work is done right. Um, and then with telecom work, however, getting it done right is more difficult than getting it done on time. The problem is mistakes in telecom work regarding your terminations in particular are difficult to detect. A mistake could keep the entire system from working properly. Um, Although a continuity test might pan out in your favor, doing a certification test might not. Um, so yeah, of course, the work has to be done on time. That is one of the things that I have a difficult time with teaching is getting things done on time. Uh, but also has to be done correctly. Um, Job one is to ensure that all determinations are done correctly. This is by far the most important part of supervision. Make sure that your people are properly trained, that they have the right parts, do not rush, have a well lit work area, and have proper test equipment and know how to use it. Next, be very sure that your people mark every run of cable and termination well. Label both ends of the cable and in multiple spots. Spend money on cable markers and numbers. Spend time on written cable and termination schedules. Do not lose track of which cable is which. Look over the shoulders of the people who are doing the jobs. Make sure that they're doing everything right. Terminating telecom cables is fine work. Make sure that your people work like jewelers, not like framing carpenters. An old joke we used to have when I used to work construction was, how do you tell the difference between an Amish framing carpenter and an Amish finish carpenter? That would be the size of their chainsaw. We also want to talk about inspections. Okay, inspections is a bit of a wild card in telecom installations. Electrical inspectors do not always inspect communication wiring. Nonetheless, take a moment to check with local electrical inspectors before you do any work on their jurisdictions. And obviously, you should be very familiar with low voltage requirements in the National Electrical Code. In most cases, the inspector of your installation will be the same person who signs the contract, although in some cases, the inspector might be a third party. Okay? Know who your inspector is. Know what your inspector is expecting of you and what he or she will be looking for. Be especially careful of third-party inspectors because they're getting paid to find your mistakes. Okay? The bottom line in installation quality is signal quality and strength from one end of the network to the other. So be careful of the details that may be noticed by an inspector. Pay attention to any detail the inspector is likely to look for, and be sure to give this a good deal of thought before you begin or even bid the project. Okay? When it comes to abandoned cabling, okay, the new provision in the 2002 NEC code requires that the removal of abandoned cables as fire hazards. Abandoned cables are those no longer in use and not tagged for future use. It's generally assumed to mean that all early coax cables used for LANs or mainframe computers, all unused Cat3 and Cat5, and any other cables replaced by newer generation cables should be removed. Now, all those cables are contributors to fire and smoke and are considered to be hazardous. Now, note, however, that this requirement applies only to accessible cables. So, although inspectors are supposed to include abandoned cables in inspections of new installations, few data voice installations are actually inspected, and inspectors may not know how to recognize abandoned cables. So, end users also do not appear to understand how to interpret this provision. In some areas, landlords are becoming the enforcers of this code, requiring those who are installing cables or vacating locations to remove the abandoned cable. We've seen offices where layers and layers of cables are left above ceilings or below floors. And archaeological reminders of the numerous generations of copper cabling installed over the years. When installing a new generation of copper cabling requires removing the old cable, it can become expensive and even time consuming. So something that you might want to look at when you're possibly bidding a job. Okay? But it's also important to remove them as a lot of those cables do not meet today's fire codes. And therefore, if there's a fire in a building, they could cause the fire to spread faster or even spread toxic fumes throughout the building when they're burning, thus putting our first responders in danger. Okay? In conclusion, for the most part, the largest part of telecommunication systems is the cabling system. It also takes the most time to put into place. And in addition, it usually is one part of the most with the most safety risk attached to it. There are only 3 risks associated with the cables themselves, but they must also be installed near or in conjunction with electrical systems. That being said, the telecommunications equipment is almost always the most expensive part of a system and must be handled carefully. That's it for today. Hope you enjoyed our presentation. Hope you found it useful, and we'll see you back for chapter 4.